Let's talk about measuring a home. This topic is very in-depth and it will be broken into multiple sections. Don't forget that measuring a home is part of your required homework. So let's talk about it. In North Carolina, we utilize what is called the Residential Square Footage Guidelines. So we're going to look at that book. And so this is the standard that we use as licensed real estate professionals in North Carolina. Now, I will go ahead and give you a note here. There are two different standards that are completely acceptable. The other is called the ANSI standard, ANSI, which stands for the American National Standard Institute. And that is the standard that appraisers use. Neither is wrong, but there's some slight differentiations, especially in the way that we calculate above grade versus below grade. We're going to talk about that. But understand the biggest thing, without a doubt, is measurements of homes are based on exterior measurements. You are standing on the outside of the house to measure as long as that's practical and possible. If you ever couldn't measure from the outside for some reason or another, you would need to add 6 inches to account for the fact that you measured inside. But it is very important to know that these measurements are all based on exterior measurements. Okay, very important. And so the residential square footage guidelines, I told you, are put out by the commission, and they kind of give us all the rules and things that we need to know. I told you, the Real Estate Commission does not say that square footage is a material fact in North Carolina. They don't even require us to disclose it. We talked about this previously. The Multiple Listing Service requires us to disclose it. And the commission says if we're disclosing it, it needs to be accurate. And that's where we have to have the requisite knowledge and possess the expertise, if you will, to arrive at an accurate square footage of a piece of real estate. Are you going to be experts after this class? No. Are you going to have a basic understanding of how to accomplish it that you can build on over, your next weeks, months, and years in the real estate brokerage industry? Absolutely. So when we're talking about square footage, there are 3 criteria that have to be present to be considered heated living square footage in North Carolina. Now, as I told you, you have to measure externally. If and only if you have to measure from the inside, I told you add 6 inches. Told you it's not a material fact, but of course you can get in trouble for saying it wrong. We do use these residential square footage guidelines, and I'm going to break something to you because I keep calling it heated living area. Folks, one of the big 3 criteria is it has to be heated by a permanent heat source. Understand, air conditioning is not required. As crazy as that sounds, it is not required to have AC to be considered living area, but it is required to have heat. Now, I don't know about you. I'm not buying a house that doesn't have AC, but it still stands that, air conditioning is not required per the residential square footage guidelines. Now, I'm going to go ahead and show you the residential square footage guidelines, and I'm going to show you where to find it, and I'm going to share the link with you because it is a very, and I normally send out on the email, but I don't think I did this time. It is a very necessary thing for the homework that I'm about to assign later today. If you go, once again, back to the Real Estate Commission's website under publications, and you go to guides right here, residential square footage guidelines. I'm going to put this in the chat, and I would suggest that you go ahead and download it and save it, because it will help you, but you can always find it here, and I can email a PDF if you need it. And so a lot of big things we got to talk about now that we're in this category. Let's start with the criteria to be considered heated living square footage, okay? As I said, there are 3. Living area, sometimes referred to as heated living area or heated square footage, is space that is intended for human occupancy and is. So criteria number 1, heated by a conventional heating system or systems, forced air, radiant, solar, etc., that are permanently installed in the dwelling. Not a portable heater, not a fireplace, something that is able to generate heat sufficient to make the space suitable for year-round occupancy. Things that would be included: heat pumps, baseboards, like I said, solar, mini splits with heating capabilities are fine because they're permanent. But you cannot include the little portable heaters. You cannot include fireplaces. Those are not sufficient, okay? So it has to have a permanent heat source is number 1. Next criteria is finished. When I say finished, I mean like finishes to the rest of the house. So finished with walls, floors, ceilings of material generally accepted for interior construction, like painted drywall, sheetrock, paneled walls, carpeted hardwood, floors, tiles, etc. And with a ceiling height of at least 7 feet. And so in a room, ceilings are supposed to be from floor to ceiling at minimum 7 feet to meet this finished criteria. Anything less than that, and we got an issue. Now, the exception is where there's ductwork or beams, it has to be at least 6 feet 4 inches. But that wouldn't be only in a part of the room would be 6 feet 4 inches, because you shouldn't have ductwork or beams in the entire room. And then there's one other point of clarity, folks, and I'm going to give you a visual on this in a second in the slides. But if you're dealing with a bonus room, like one of our garage that has sloped ceilings, there's a special rule. What it basically says is half of the room, at least half of the room, has to be 7 feet or taller from ground to ceiling, and you can only count up to the portion where the slopes are at least 5 feet from the floor. So if your slopes go all the way down to where the slopes end and there's only 4 feet from ceiling to floor, you can't count it. You would have to come away from the wall to where there's at least 5 feet from floor to slope. And that's what it says here. In finished rooms with sloped ceilings, finished attics, bonus rooms, etc., you may also include as living area the portion of the room with a ceiling height of at least 5 feet if at least one half of the finished area of the room has a ceiling height of at least 7 feet. And I'll give you a visual on that in a second, as I said. And then the last criteria is directly accessible from other living area. And so that means you can get to it from the rest of the house. So let's say that you have a bonus room above your garage and it's finished. It's got a permanent heat source. It's got drywall. It's got hardwood floors. It's nice. But the only way to access it is through stairs in the garage. You can't count it in the total heated living area number because you have to go out into the non-meeting the criteria garage to get to this room. Same thing if you were bougie and you got a pool house and your pool house is just as nice as your real house. Well, you got to walk outside to get to it. You cannot include it in the total number. I had a friend growing up that had a 2-story house, and it was the craziest thing. You walked onto the first floor, and there was kind of this living area. And then there was this stairway outside that went up to the second floor. And that was the only way to get to it. And so it was like kind of like a stacked up duplex, right? It had 2 kind of like kitchens in each one and, kind of its own separate area. If you ever went to sell that property, it would have to be separated out because it's not directly accessible. Now, folks, please understand, it can still be considered finished area. It just can't be included in the total number. So let's say that in my friend's house example, let's say it was 1,000 square feet on the first floor, 1,000 square feet on the second floor. The living area is 1,000 square feet, and then you could have other area above grade of 1,000 square feet. You got to separate it out. That's what these criteria are meaning. Now, I'll tell you the big differentiation between the ANSI standard and the North Carolina residential square footage guidelines. When we talk about above grade versus below grade, as I just mentioned, grading is when you get the lot flat and ready to build on, right? It's just moving the dirt. And so if something is above grade, it means it's above the dirt. If something's below grade, well, we call it below grade if even one portion of the wall is adjacent to dirt. So I want you to think about a foundation. It's a basement. And so if you walk into the house here and then there's like a drop off and then you got, the house kind of like this. And let's say there's a set of stairs that goes down and then all of this is finished right here. But because there's dirt on the outside of this finished living area, even a tiny piece on one wall, if there's dirt outside of one of the walls, we have to consider that below grade. So is it living area if it meets all the other criteria? Yeah, but it's below grade living area. And appraisers typically give less value to what's considered below grade living area versus above grade. Now, if you live on a crawl space, and so you've got your crawl space, your brick, your cement block, whatever it is here, the ground here, and then all the houses up above it, everything in your house is above grade. And so that's the big differentiation. In the ANSI standard, they always separate them out. So if you look right here, While real estate agents are encouraged to provide the most complete information available about properties offered for sale, the guidelines recognize that separate reporting of above grade and below grade area can be impractical in the advertising and marketing of homes. For this reason, real estate agents are permitted under these guidelines to report square footage of the dwelling as the total living area without a separate distinction between above grade and below grade areas. However, to help avoid confusion and concern, agents should alert purchasers and sellers that the appraisal report may reflect differences in the way the living area is defined and described by the lender, appraiser, and other North Carolina building code, which could affect the amount of living area reported. So let me tell you what this means. Technically speaking, you can, let's say if you've got 2,000 square feet above grade and 1,000 square feet below grade, you can advertise it as 3,000 square foot living area home because it's all connected if it meets all the other criteria. However, it would be in your best interest to disclose, and most MLSs have a separated place to put below grade. So it'd be in your best interest to disclose it so there's no confusion. And understand that appraisers, because it has a different value, they always count it separately. They do not include it. So when the appraisal report comes back, they're going to call it a 2,000 square foot house with 1,000 square feet of finished below grade. And they'll give the price per square foot different for that. That's the big differentiation between the ANSI standard, which appraisers use, and what we use as real estate brokers. Now let's go ahead and just talk about measuring, folks. First and foremost, let's talk about how you measure. Now, I'm not expecting you to go out and buy anything new or special to do this. So hopefully you have something that you can do this with. I will tell you as a real estate professional, having one of these, it's called a wheel tape, is very useful. Okay? Not the wheels that you roll. This is a wheel tape, and so it's got a little handle, and you can, retract it back, and it typically comes with a stake that you can put in the ground, and it's got spikes on it. This is the best thing for measuring houses, hands down. Is this the only thing? No. Let me show you actually on the slides really quick some other options, and I'll backtrack here because I just want to talk about this real fast. I should have an image here. Right there. So, wheel tape, best thing. Standard tape measure, it can be done. And then, of course, a laser tape measure. I don't care how you do it, but whatever tool you use, I hope you know how to use it. And so, if all you have is this, it is possible to do this assignment with just this. It's a little more work. This is the best. And this can sometimes make your life easier, but I'll explain kind of why it may or may not in just a second. So now let me explain how you actually measure a property. Let's look at an example here. Let me try to readjust this. So let me show you a house. And that's the cool thing about this book. It gives a lot of examples of a lot of different houses. So I'm going to zoom in. Let's just call this house a ranch. Now, obviously, this has a basement, but I don't want to talk about the basement yet. And so this has a covered front porch, and then it has kind of an outjutting that comes out, and then it kind of goes back around. And so it's what we would call kind of like an L-shaped ranch. And so if you look at it from an aerial view, it's got a little outjutting. And so when you're doing measurements, I told you, you are basing it off of the exterior measurements. And so what I would do personally, if I was measuring this house, I always like to start at the front left of the property. So I would go out there with my wheel tape. I would come to this first corner right here on the left on this porch. I would attach my wheel tape, and I would measure that first wall into that inside corner right of the front door. And if you look, and my recommendation is to always use graph paper when you're doing this. But after I make that measurement, I'm going to draw my line on graph paper so it's nice and straight. I'm going to put my measurement 28 feet. And so after I got my first measurement, now that I'm inside this corner, I'm going to measure from the inside of this corner to this outjutting, this wall right here. And when I do that, I'm going to write that down, and that's 3 feet. And then I'm going to come across this front wall right here. Measure from here to here. And I'm going to write that on my graph paper, and I'm going to put my 22 feet. And then I'm going to measure this corner to this back wall. Graph paper. 33 feet. And I'm going to measure across the back side. Now, folks, let me give you some word of advice here, and I'm going to talk about some best practices and some things to be aware of. This house has a chimney. And so the chimney, meaning this brick outjutting right here, that is not part of your heated living area. Now, it's a lot easier than some of you probably realize. And I'm going to tell you one of the hardest things about measuring houses. And I'm just being completely honest. Some people have really good spatial reasoning and spatial awareness, and some people have very terrible spatial reasoning and spatial awareness. And I'm going to say that 1,000 times in this class, but you have to understand it's true. Because some of you, this might hurt your feelings when you realize you don't have good spatial awareness. Some of you may have it. But here's what happens. If you were to sit there and measure all of this, you're making your life harder. And you can't just loop around it, because then that's not going to be an accurate measurement. Here's what you do. You measure from here to here, here to here, and here to here, and add them all together. And now you've got the backside of the perimeter. Does that make sense? You don't need to measure. I mean, you can for the sake of closing the picture, but basically what you know is, because you can't do a straight line from here to here, if you go here to here, and let's say this is, 30, and then this is 3, and then this is 17, and then you get your 50 all together, whatever it may be. And you just add them together, because this plus this line is the full linear backside. Everybody with me? Don't reinvent the wheel. It's a lot easier than sometimes we realize when we're doing these things. So you get those measurements. Of course, you can measure and just know that you're not counting this part, so you can close it for like a floor plan or a drawing or whatever it may be. And so then I come from this side to this side, and always do the last side. Why? Because you want to make sure that things close off and they're plumb and square. Otherwise, you can't really check your work as much. And now you've got your layout, folks. That's how you measure a house. That's it. There's more specifics that we got to get into, but next piece is calculating. So let's teach you this. If you look at this picture, okay, you've got to remember some rudimentary math skills from grade school, like calculating area. Who remembers the area calculation formula for a rectangle?
Length times width times height.
Don't need height. That's cubic. Yeah, there you go. Just length times width. Length times width, because we're dealing with square feet. We don't want cubic feet. We just want square feet. And so it's length times width. Well, folks, if you look at this, it's almost a rectangle, but it's not quite. But don't fret. All you have to do is draw a line from here to here. And now you've got one big rectangle and one little rectangle. Everybody see that? Don't overcomplicate these things. Yeah, this is a weird L shape. There's no formula for this L shape. But if you just separate it into two rectangles, now you're just taking your length times your width. And so this rectangle, folks, and this is where spatial awareness comes in, this whole side is 33. But that's not the side of the rectangle I just made. From here to here is 30 feet. Why? Because this is 3. So if that total length is 33, then this is a 30 by 50 rectangle. Everybody see that? This large rectangle is a 30 by 50. And so now, all you have to do is your length times width for that rectangle. 30 times 50. Oops. 30 times 50. And so this large rectangle is 1,500 square feet. And so now this small rectangle is 22 by 3. So that would be 22 times 3, or length times width, for 66. And so this is a total of 1,566 square feet. Now, folks, when you do this at home, like I said, do it with graph paper. And don't go out and buy graph paper. You can literally type in on Google, graph paper PDF, and print one sheet of it. It's so easy. But the other thing that I suggest, because yours may be a little more complicated than this, when you divide it into quadrants, label them. Let's call this A. Let's call this B. And then do the math on the side. A is 1,500. B is 66. Add them together for the total square footage of 1,566. Everybody with me so far? So let's just start adding in some different variables, if you will, because it's sometimes a little more complicated than this if your house is a little more complicated. So let me just throw one thing. Let's leave everything the same. However, I'm going to pretend that this ranch house has a garage off the side over here. And I will call it a 20 by 22 garage. Well, folks, if you can figure out exactly where the garage ends from the outside, it's very easy to just do, your 20 by your 22. Of course, because sometimes from the outside of the house you can't tell where the garage ends, more often than not, what you do in a garage is you will come in here and you'll measure from the back from here to the inside wall, and then you add 6 inches to account for the exterior because I had to measure from the inside. And then you come here to the exterior wall and you add 6 inches to account for the fact that that's an exterior wall. And then you can take that and now you've got your dimensions. So if this was, and I'm going to backtrack here, a 20 by 22 garage. Well, the first big rectangle here is 1,500 square feet. But if I wanted to figure out the area of the garage, it's 20 by 22. So I would need to subtract 440 square feet from this house because the garage is not part of the living area. And so 1,566 minus 440. If this was a ranch home with a garage, the living area is 1,126. And the garage is 440 square feet. Everybody still with me? Okay. Let me add another variable in here. If you're measuring this house, let's pretend this house is what we would call a true 2-story. And when I say true 2-story, I mean it is the same on the first floor as it is on the second floor. Well, all you have to do to measure out a true 2-story is figure out the first floor and multiply it by 2. But here's the thing. In this example, without the garage, if this was a 2-story home, it would be 1,566 times 2. So if this did not have a garage and it was 2 stories, it would be a 3,132 square foot house. Does that make sense for everybody? If it's the exact same on the second floor as it is on the first floor. But since I added the garage, you would take the first floor, multiply it by 2 to get 3,132, and then you still need to subtract out the garage after you do this, because if there's living area above the garage, you can't subtract it out first. Otherwise, you're going to pretend there's no living area of the garage. You see the problem? And that's where this spatial reasoning comes into play. So after you calculate the 3,132, now subtract out the garage on the first floor only. If this was a true 2-story, but it had a garage that was 20 by 22 on the first floor, this would be a 2,692 square foot house with a 440 square foot garage on the first floor. Is this making some sense? Now, I'll tell you that it's a lot easier for me to explain it via textbook. When you get out there and you start looking at a house, you're going to have to start looking at lines. You're going to say, okay, that lines up with that. That stops short's there, but it lines up with this, and so I can measure from here to here, so that's 20 feet, so I know that's 20 feet. Because it's not really practical to get on a ladder and start measuring outside if you don't have a true 2-story. So you're going to have to use correlation points to figure out the size of something. And you got to get a little creative sometimes. And this is where it takes practice to figure out what kind of makes sense and what doesn't. And I'm going to warn you of something while you're measuring, okay? I'm going to be completely honest because I made the joke yesterday. I'm going to make it again in a different context. Folks, when you are measuring houses, you've got to understand that you're going to get exposed to a little bit of nature. Because people have bushes, people have flower beds, people have trees, and critters exist. I have been bruised, I have been scraped, I have been in thorns, and I've been attacked by spiders and bees. Because if you get out there and you start measuring a house, folks, you're measuring the outside. If there's a bush here, a bush here, a bush here, you're having to fiddle fart your way back behind bushes. And you best believe you're going to get some spider webs in the face. Let me tell you what I do. You ready for this? I pick up a stick and I pretend I'm Zorro. I'm just sitting there swinging it around before I go anywhere to make sure I kill all the spiders, all the webs, all the everything. Just ha ha ha, putting the Z in the sky. Just writing my name in the air with this stick to make sure that I'm not walking through a spider web. Because I told you, if I walk through a spider web, you're going to see me speaking in tongues and praying to Jesus. Okay? I don't like spider webs. All right? Makes me uncomfortable. And I got a big old beard. They get tangled in there and I'm just, right? I don't like it. But just be prepared for that you're going to kind of get exposed to these different elements. Now, of course, there are a lot of different styles of houses. Now, and this isn't a huge class, and so I can field more questions in this class, but the cool thing is this will start to give you some insight into different things. This one has a basement. Well, let's talk about some differences when you've got like a vaulted opening, folks. This is a 2-story house. And it's almost what I would call a true 2-story. It's basically the exact same on the first floor and the second floor. The only difference is it has a bay window. Now, bay windows, it will talk about because up here, there's details on certain features like stairs, like bay windows, like laundry rooms. So I want to show you where that's at the beginning. Dormers, furnaces, breezeways, bay windows. If it has a floor, a ceiling, height of at least 7 feet, and otherwise meets the criteria, you can count it. If it doesn't, you can't. So let's assume in this example, it's one that you can count. Well, I'm going to teach you another mathematical concept here before I go into real in-depth here. This bay window can be a little intimidating. Okay, let me kind of expand it for you. I'm going to put it this way. And so here's your bay window. And it gives us the dimensions. It's 6. And then this is 4. And then this is 3, right? From here to here. Now, folks, what geometric shape is this bay window? Who remembers what it's called?
It's a polygon. What is it? I don't know.
That's what I love about adult learners. A lot of us forget some of the most rudimentary things.
Is it a parallelogram? I can't remember.
Is it a trapezoid?
It's a trapezoid. Yeah, it's a trapezoid, folks. Now listen, there is a formula for calculating the area of a trapezoid, and I'm going to be the first one to tell you, don't nobody need that negativity in their lives, okay? Forget that, all right? Because it's like base 1 plus base 2 divided by the half. It's something stupid. And so let me show you what it really is and make your lives easier. It is, in fact, just 2 triangles and a rectangle, isn't it? You see that? If I draw an imaginary line here and an imaginary line here, there's a triangle, there's a rectangle. Now let me show you something cool. If I was to take a look at a rectangle, you already told me, and this is a crooked rectangle, but you know, whatever. You already told me that the formula for calculating a rectangle is length times width. Don't get so caught up on those words. Really, it's one side by one side. So we'll call it length times width. And so that'd be the area of all this. Well, folks, watch what happens if I draw a line from here to here on that rectangle. What did I just do?
Split it in half.
Split it in half, more specifically into 2 equal what?
Triangles.
Triangles. Folks, the formula for calculating the area of a triangle is technically 1/2 base times height. Or in other words, base times height divided by 2. And here's why. If I instead call this base and call this height, if I just did base times height, that's actually the formula for a whole triangle or a whole rectangle. But if I take those numbers and divide it by 2, I have found the area of that triangle. You agree? That's it. A triangle is 1/2 base times height. So let's say that this was a 6 by 8. Okay, well, if I did 6 by 8 for this rectangle, 6 by 8, that is a 48 square foot rectangle. But I want to know what the triangle is divided by 2. Area of one of these triangles is 28 square feet. Everybody with me? So now that you know that, this bay window is not nearly as intimidating. Look what we got. We've got one rectangle that's 6 by 4. So a rectangle is just length times width, 6 times 4. Or 24 square feet for this rectangle. And I'm going to circle it so we don't get it confused. And then this triangle is a 4 by 3. And so base times height divided by 2. This triangle is 6 square feet. This triangle is also 6 square feet because they're identical. So this bay window is 36 square feet. Everybody with me on that? Now here's the thing. This is a true 2-story house with the exception of that bay window. And so you need to keep that bay window separate until the end. Because if you add it into the total square footage initially and multiply it by 2, it's not on the second floor. So you're going to mess up your numbers. So now watch what happens. Let's leave this in its own little island, pretend it doesn't exist. This is a 40 by 30 rectangle otherwise. You agree? 40 by 30. So 40 feet by 30 feet. So the first floor is 1,200 square feet. And so now you would take that and multiply it by 2 to get the second floor. Now, I want you to pretend for a moment, and I'm going to explain the actual thing, but I want you to pretend for a moment that it is the same on the first floor and the second floor, just so I can paint a picture, and then we'll pretend that then we'll go to the catwalk that it actually has, or the vaulted opening. So now, if this was 2 stories without this vaulted opening, it'd be 2,400 square feet plus our 36 square feet for the bay window, for a total of 2,436 square feet. If it was same on the first floor and the second floor. It's important to note that stairs count on both floors as long as the opening for the stairs is the same on the first floor and the second floor. If you've got like a caddy turn, or if you've got, a wider opening, it gets a little bit weird. But that would be how you would do this if this was a true 2-story house. Now, let's explain what's actually happening in this house. In this house, there is a vaulted opening. And so you walk into the foyer and you look up, and there's probably one of those giant chandeliers, and it goes all the way up, which means there's no living area on the first floor. So we calculated it as if there was. So you've got 2 options here, folks. You can, of course, try to figure out on the second floor these little pockets, because you don't need to subtract where the stairs are, because the stairs technically count on both floors as long as the opening's, normal opening. And so it gives you an explanation up here, and it's going to mess me up a little bit. So what it's having you do is treat this like a rectangle and treat this like one, and you find the area of this L shape and you subtract it out. So the reason why they did it this way is more specific. Let me just show you here. If this was 10 feet by 12 feet, that would be this whole pocket, but you don't need to subtract the whole pocket because the stairs count. So 10 by 12 is 120, but you can add back in the stairs, which are 6 by 4. So 6 by 4 is 24, so subtract out that. And so all you're really taking away from the second floor would be what's left, 120 minus 24, because we can leave that in. So subtract out 96 square feet. And so if we were finding the square footage of this house, it is let me put that in here, 96. First floor, which is 1,200, times 2, minus 96 for this vaulted opening, that L shape, plus 36 for our bay window on the first floor. 2,340 square feet. Now, yet again, I'm not including this little bonus room over here. I'm trying to stick with the simplistic pieces first. But does everybody kind of see what I did there? And I'll tell you, it takes time to get used to this. It's not fun. Nobody likes it. It's a pain in the butt. But there is walkthroughs on how to do these different things. So it does explain the bay window here just like I did. And then it does explain kind of how they're calculating things a little bit differently and adding the stairway back in. Now, I did mine where I just took the whole thing and subtracted it. But that's where spatial reasoning comes in. There's more than one way to do things as long as you get comfortable with kind of the numbers, the structures, what counts and what doesn't count. So let me add another really big important criteria, and then I'm going to let you practice the math, and then I'll circle back around and we'll start just talking about some specific scenarios, okay? I told you that you can use the wheel tape, you can use a standard tape measure, and you could use a digital tape measure. Let me give you some tips here. Let's go back to this first one because it's a good example. Wheel tape, let me give you a trick I learned over time. They're sometimes hundreds of yards or hundreds of feet long, and so you can take a wheel tape, imagine that this wasn't here, and go from one end all the way to the other. I don't recommend that. Here's why. you really have to pull with some strength to keep that line taut. Otherwise, it'll start sagging, and then your numbers aren't as accurate. The other thing that you have to be aware of is they have teeth. So if you're pulling that hard, you may be damaging vinyl siding on your client's house, scratching their brick or something like that. Here's what I've learned in my years of doing this. Walk with it. So if you start at the corner, hold the tape there, stretch your arms out as far as it'll go, pin your thumb there, and then move over. And then keep walking with the tape. So the other side just drops loose after you've measured. And so you always keep it tight because you're only measuring as long as your arms will go. And so it's always a very tight, easy to walk with number. And it also makes it easier when you get to a certain point and you have to stop, like at a drain spout or something, and you can mark the number you're at right now, measure the front of the drain spout, and then move past it on the next side and then add it up. Does that make sense? Now, if don't have a wheel tape and using a standard tape measure, you're going to have to do that anyway. Because let's say your tape measure is 25 feet. You're not even supposed to pull them the whole way out. So what you're really going to be doing is you're going to be measuring your 20 feet, stopping, pinning, measuring another 20 feet, stopping, pinning, and then measure your last 5 feet. And so you're going to have all these bracketed numbers that you're going to have to add up because all your tape measure will go to certain distances. But you can do it with a standard tape measure. Now, here's the last thing. Let's talk about the digital tape measure. They're fantastic, but I'll tell you this. Digital tape measures are way better for measuring the size of rooms inside, and I don't need you to do that for the assignment I'm going to give you. I just want to know the square footage. I don't need to know where the rooms are. I don't need to know the size of the rooms. Here's the reason why digital tape measures are not great for outside. Number one, they use lasers. Lasers are not nearly as accurate when the sun's out and it's super bright out. The other thing is lasers have to hit something. So that means you're going to hold your tape measure, digital tape measure, up to this, and you're going to aim it this way, and you're going to fire it. Well, there's nothing to hit. It's going to keep on keeping on. What that means is you either have to take a person with you to hold something up along this edge, or you're going to have to take a board with some tape on it, like a piece of cardboard with some tape, and stick it there. So then that way when you fire the laser from here to here, it hits it, and then you can get your measurement. Does that make sense? They're great if you know how to use them. The only other thing for digital tape measures is knowing how they're calibrated. Some of them are calibrated where they include, like, let's say the tape measure is 4 inches. So when you get your number, it accounts for the fact that the back of it was there, and that's that 4 inches. Other ones, you have to add the 4 inches back in manually because it only goes from the front of the tape measure to that. And if you know the tape measure is 4 inches, then you'd have to add it back in. So there's your kind of lesson there. Now, folks, let me give you your last big, oh crap, this sucks lesson. Okay, you ready for this? If I was to say, let me think of how to put this, and then I'll show you what I mean. If I was to say 1 foot, 6 inches. How many total inches is that? 18 inches. If I was to say 1.6 feet, how many inches is that?
I feel like that's a trick question. 18?
It's not. And that's the problem, and that's the point I'm trying to make. Because 1 foot 6 inches, inches are based on a 12 inch per foot scale. Decimals are on a 10th scale. And so 1.6 feet, I see some of y'all doing the math, folks, that's the same as saying 12 inches times 1.6. That's 19.2 inches. Do you see the difference? So this is 19.2 inches. This is 18 inches. And you have to understand that when you're measuring. Here's what I mean. On those wheel tapes, there is typically 2 sides. There is what we call standard scale, and there is engineer scale. This is standard. This is engineers. And it doesn't matter which one you do, so long as you pick one and you stick with it. And I'll show you how to do the final calculations. But if you start putting 1 foot 18 inches and then another one you put 25.2 inches or 25.2 feet, it's not going to be right. You got to pick one and stick with it. So you either go with like 28 feet 6 inches or you go with 28.54 feet or whatever it is. Does that make sense? Now, I'm going to let you practice some of the math concepts now in a very simplistic fashion. And then I'll come full circle and I'll teach you how to do the calculations and answer any other questions on the measuring. So let me give you some visuals here, folks, to let you practice this. And I'm going to warn you, it's going to hurt some of your feelings because some of you may realize that you don't have spatial awareness quite to the extent that you thought you did. So here is an example. I want you to take a look at this floor plan, okay? Let's say this was your house. You measured it. It's got a bay window. All of this is living area. You can count all of this. Well, just like that first example we did, we've already talked about this. It's an L shape. So what you need to do is you need to break this down into manageable bite-sized pieces, geometric shapes you can calculate. And I'll help you out, folks. If it was me, I would go rectangle, 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 triangle, triangle. And you add them all up. Find the area of all these things and add them up. Folks, keep track of it. A, B, C, D, E. So that way you don't lose anything. So take a minute, work through this. Tell me how many square feet this property is.